Thinking about trustful collaboration in digital value networks, about data exchange in digital value networks, you need to consider the benefits, because you obviously only engage in data sharing when it gives you benefits. So this is the stylized decision process, how to weigh benefits against risks. And in this video, I'll focus on the benefit part. So the benefits are obviously always context, objective, use case specific. And you need to see which data you want to share with your partners in the value network. And then start with the statistical, the machine learning, the artificial intelligence modeling to calculate the benefits. Which data are we talking about? We're talking about data either coming from sensors in the smart industry, in the industry 4.0, or from the engineering with the digitally integrated engineering in an industry 4.0 setting. Both is the data. This might be shared data among different partners in the digital value network. You use this data for statistical analysis, for machine learning, for artificial intelligence. This might lead to operational benefits and this might lead to economic benefits. And what you see in this spaghetti chart down there, which is not meant to be read, it's very small font, is that there are many different paths from the operational benefits to the economic benefits. So what we did here is, in a project with multiple partners from industry, assess in detail if the manufacturer of a machinery tool and the user, the customer of that tool, who uses it in manufacturing processes, share data one way or the other, one direction or the other. What are the potential operational benefits for improving milling processes and the design of milling tools? And what are the economic benefits coming out of that? And what you see here is that it's a very diverse set, a very broad set of potential benefits and how they are interlinked. Rather than looking at all of them, let's look at some of them in a little more detail. And as it's still quite small font, I'll zoom in a little. What you see here on the left-hand side is that we start with saying we want to look at the operational benefits. And we highlight two of them, the predictive maintenance part, or the improvement of milling tools through workpiece and process optimized design. But let's start with predictive maintenance. It's more general, less specific. Predictive maintenance means that you don't do time-based or condition-based maintenance when your machine has already run down, when your milling tool is already broken or the like, but that you do predictive maintenance. You use data to predict when maintenance is required. You can then plan it and have planned maintenance, which is typically less costly and better integrated in the production process than unplanned maintenance. What is the result from predictive maintenance? Well, for example, it's reduced maintenance work. It's increased machine service life. Or it's the prevention of unplanned downtime. What does this lead to? Let's look at the prevention of unplanned downtime. Well, it leads to preventing expensive purchase of spare parts if you need to place rush orders. It prevents the provision of safety machine capacity to jump in when your machine breaks, because you don't have such unplanned downtimes. And it leads to improved adherence to delivery dates. What is the result of that? Well, there are multiple results, as you see by the many different arrows. But for example, if we look at the improved adherence to delivery dates, then increased customer acceptance is a result. What does increased customer acceptance lead to? Well, it might prevent price reduction, or it might increase sales. And now we're at the level of economic benefits. This was one example how the operational benefits from data sharing improve predictive maintenance, because data between supplier and customer is shared, allows for economic benefits here on the customer side. We can also move this path backwards and say, okay, economic benefits, which economic benefits might we have? There is prevention of price reduction, increase of sales, or also reduced personal costs, but let's go for increased sales for the moment. How can we increase sales? Well, there are different arrows pointing in. One is, for example, by increasing throughput with a given capacity you have. Now, how can I increase throughput? For example, by reducing cycle time. How can I reduce cycle time? By reducing rework required. Once you perform a process step, for example, milling of metal, then there might at the end be rework necessary if quality is not correct. And this rework obviously takes time and leads to costs. You can avoid that if you have improvement of the milling tools through workpiece and process optimized design. But for the manufacturer of the milling tool, the supplier of that tool, to perform this improvement of the milling tool, the supplier needs data how the customer exactly uses the tool. What are the processes? What are the work pieces on which these tools are used? And if the customer shares that data, not only the planned data, but also the operational data from manufacturing processes with the milling tools, and if this data is shared back to the supplier, then the supplier can use it to improve the milling tools and thereby then reduce rework. And as we saw before, this might reduce cycle time and reduces personal costs, which leads then to the economic benefits. And this was just a small example from this larger network of potential operational and economic benefits you can get from sharing data within value networks. Now, obviously, only identifying these benefits qualitatively is not sufficient. Once you know which qualitative benefits are there, you need to quantify them. You typically do that by trying it out, by running experiments with, for example, the old process, the new process, the old tools, the new tools, and the like, and assessing the machine costs, the personnel costs, and other types of costs you have in these different treatments in the experiment. You compare it to each other, and then you see what the change of costs is, and then you can quantify the benefits. Here we see a stylized example for this improved milling tool to workpiece and process optimized design, which I talked about on the previous slide. In the standard setting, you might have standard machine costs for the infrastructure, for the material and the like. You have personnel costs, and you have tool costs on top of that. Now, if we have optimized tools, then likely the tool supplier has higher costs and wants to have a higher margin, so tool costs might go up, which is, from the customer's perspective, a bad thing. But then hopefully these increased tool costs are offset by, for example, shorter production time, which reduces machine costs, which reduces personnel costs, and might overall, in the innovative setting, based on the data sharing part, lead to lower overall costs. Whether that truly plays out and how much lower or not these costs are, well, that's very context, very scenario, very process and so on specific. So you need to calculate that and measure it in experiments for the different settings. But hopefully, if you come to these net improvements, then you can see that data sharing might make sense in this specific use case. And then you can start assessing the risks which are associated with sharing this data and weigh the benefits against the risks.